Hello chemistry students. Today we're going to begin our unit on solution chemistry, but before we talk about solutions, we need to talk about water, because water is it plays a big role in solution chemistry. So let's talk about some properties of water. First, water has a unique role in chemical and biological systems. You've probably learned a lot about it in biology. And the first thing is water's hydrogen bonding, and that is the bonding between a hydrogen on a water molecule and an oxygen on another water molecule. This little bond right here is called a hydrogen bond. Now, it is simply the attraction between the positively charged hydrogen and the negatively charged oxygen on another molecule. And it creates a very weak bond. It's not like an ionic bond where you give away an electron and one atom takes an electron. They're attracted because they have a strong charge. These are not a total negative charge because of an electron has been taken, and a total positive charge because an electron has been given away. It is a partial charge, which means the electron spends most of its time on the oxygen and some of its time on the hydrogen. So it has a slight positive charge and a slight negative charge. And because of that, they're attracted to each other, and that's called hydrogen bonding. Now, that means that water's polar. Now remember, polarity is like opposites, like the north and south pole. They're opposite of each other. Well, polarity in chemistry means that there are charges and they're opposite charges. So the water molecule right here, this one water molecule, it's polar because the electrons that are shared between the hydrogen and the oxygen spends most of its time on the oxygen atom. And since it does that, that means that it's polar because it creates a slightly negative charge. And because that electron is not spending as much time on the hydrogen, it has a slightly positive charge. Second property of water is cohesion. Now, the properties that we're talking about are due to the hydrogen bonding of water. Cohesion is just the force of attraction that holds molecules of the same substance together. So we talk about water molecules, like right here. Here's a water molecule. And because of its hydrogen bonding, attract each other. You have this little bond right here going because of that. And a paper clip can actually sit and float on top of the water. Now, a paper clip, you should know, is more dense than water, so it should sink. But because of the hydrogen bonding, these water molecules are sticking together and preventing the paper clip from sinking. So that is a hydrogen bond. It is easily broken because you should know that if you put the paper clip down, just push it a little bit, it's going to sink, and you'll break that bond between the water. And this is why insects, if they don't provide too much force, they can walk on water. It's also why it's very painful when you do a dive and you land on your face or your side, and it's because this hydrogen bonding surface has not been broken, which is why typically you want to land on your feet, because your feet will break that. Or you want your hands, if you're doing a dive, you want your hands to break that water tension right there so you can go in without it slapping and providing a force against you. Third property of water is adhesion. It is the attraction between two different substances. Now, adhesion is different from cohesion. Cohesion is between water molecules attract to other water molecules. Adhesion is when water molecules attract to other substances. Fourth property of water is density. Water is more dense in its liquid state than it is in its solid state, which is the opposite of what most compounds do. Most compounds, when they become a solid, they get more packed together and they become more dense. But water is not like that. I am going to show you a little interactive here. Okay, here we have some water molecules in its gaseous state, so as you can see, they're bouncing around. The red part stands for the oxygen. The white parts on these molecules stand for the hydrogen. Now I'm going to put it in its liquid state, and as you see, we got some gas molecules up here, but as you can see, they're still moving around and bouncing around. Our liquid state, they're fairly close to each other. There's some space between them, not a lot. Now let's cool this down and go to its solid state. And when I do that, you'll notice that they start to crystallize. And when water crystallizes, it has a bunch of empty space in it. We've got one little water molecule over here bouncing around, or a gas molecule. It starts to crystallize, and when it does that, you've got some empty space in here. And that empty, a lot more than in the liquid phase. And because of that, it makes it less dense, because it will take up more volume. If you notice, there's more volume here than in the liquid state. Let's heat it up and I'll show you. See, it takes up less space in the liquid state than it does in the solid state. Right here. Here's the solid. Here's the liquid. The liquid takes up less space. The solid takes up a little bit more because there's some empty space in here, which makes it less dense. Now, water is known as the universal solvent, which means it dissolves lots of things because of its polarity. Now let's look at another. Now, here's some water molecules. We're doing a close-up, and if you notice, the hydrogens are attracted to the oxygens. They're lined up that way. There aren't very many, if any at all, oxygens touching another oxygen. Occasionally you will see it. All right, now let's put some salt in there. Now, salt is an ionic compound. We put it in there, and what does water do? It dissolves it. It separates the sodium and the chlorines. Oxygens are hooking up or aligning themselves to where they're close to the positive side, because positives and negatives attract. And if you notice that all around this sodium, there are oxygens are lining up with it, as opposed to on the chlorine, it's all the hydrogens that are lining up with it. And that's what actually makes them dissolve, because the water molecules pull these ions apart from each other. Now let's look at sugar. Let me reset this, and let's look at our sugar. Now, sugar is not ionic. It is covalent. Unhighlight the sugar. I put the partial charges on all the water so you can tell the difference. Sugar is made up of hydrogens and oxygens as well, and they are colored red and white. And if you notice, the oxygens will line up with the hydrogens on the sugar molecule. Now I'm going to highlight the sugar molecule because you can see it's so difficult to see. But that's how it dissolves it as well. Now water can dissolve, because it's polar, it can dissolve many, many things.